Testing, testing, testing. Testing, testing. Testing. Testing, test. Testing, testing. Testing, testing. Live. We're live and the audio is working. All right. Verification going. By stream verification, I mean watching it on a separate external YouTube account on a different monitor and making sure that it doesn't freeze, that audio, and so on. All right. So first of all, I'd like to thank people for the 100 subs. I know it's a tiny amount of subs and not a lot of people and not necessarily something maybe I should be proud of, but I am proud of it. Happy that got some people watching this. All right. So today we're going to continue with our Kaggle using ChatGPT. So what we're doing is we're solving this Kaggle problem about protein folding. Specifically, there's not folding, but it's trying to predict the temperature maximum of a protein. So at what temperature does a protein start to deform? And there's a data set that was given to us by Kaggle that train.csv, which contains, as you can see here, over 30,000 rows of data, where that data has all kinds of things in it. It has the protein sequence, it has the pH, it has the data source, and then it has the actual temperature maximum target, right? This is a regression problem. You're trying to basically find or predict the TM. So yesterday we created this embedder Python script, and we were basically encoding the protein sequence, which in the raw data set is just a string like this of just the amino acid sequence. And then we created that embedder, which went ahead and used a couple pre-trained models in order to these.csv in order to convert that that string of amino acids into a latent vector or an embedding that has a little bit more knowledge, a little bit more information that hopefully we'll be able to use with a learning model. So I'm just going to cut straight to the bad news here. The bad news is that it didn't run on all 30,000 lines. I ran it all yesterday night, and it still only got to around 15,000 lines, 14,000 lines. So we don't actually have the full data set, basically. We only have about 15,000 lines worth of data. And we were only able to do it with two different models. We have the ESM2 650 million parameters trained on the UR50D dataset, and then we have a ESM1 also 650 million parameters trained on the UR90S dataset. So we're gonna go ahead and kind of pretend that these worked, and we're going to treat them as if they're the full 30,000 rows, and we're going to continue. So today what we're going to be doing, let's put this in here. So this is some messing around we were doing yesterday. We one thing we did is we kept running out of memory, so we went ahead and shortened it. So you can see here that the max sequence length is 1024. So for the ESM2 model, we only use the first 1,000 amino acids in the sequence. So ideally, we wouldn't have to do that, but we were running out of memory. So that's an issue. But I think we can go ahead and just move into the next part of this, which is going to be doing the actual training. So save all this. Actually, Control-Shift-G in order to pull up the commit here, and let's commit the two things yesterday night, and let's say reduce max sequence length. Okay. Control KW, and that'll close all your current windows. Closed VS Code. So let's go ahead and reopen it. But first, let's pyenv activate ESM protein, which is our Python virtual environment. Then let's go into our dev folder. Inside that, the betterer folder, and inside that, the Kaggle folder. Inside that, the enzyme folder. Open up VS Code in that folder. And let's make a new Python file here. Let's call it train.py. And so in this Python file, we're going to do a couple different things. We're going to make a data loader to load training data from CSV files. We are going to, what else? Create a model. And in this case, it's neural network, so little MLP, to train on the sequences. And we're going to have a training loop function. Then we're going to have our testing loop function. And yeah, let's start with that. So we're going to need a couple dependencies here. We're definitely going to need torch. We are definitely going to need potentially pandas, but go ahead and go to our best bud here, ChatGPT, and we're going to say, can you write Python code that finds a PyTorch data loader that can load batches of data from a CSV file. See how ChatGPT is working today. Okay, so it's extending the torch utils data loader class, which is correct. It's reading the CSV file. It wanted to use pandas, which is fine. Um, okay, so it's converting the entire data frame into a PyTorch tensor, and it's creating the data set from the tensor, and it's this is a little simple. I think this will load the entire tensor into memory. This data loader will load the entire data set at once. Can you modify so that it loads only a part of the data frame so that it loads only one batch of the data frame at a time? Error. Okay. Okay. I think this is enough to kind of get started with, though. So we have our copy paste our little data loader here. If we can start a new thread here, ask to write Python code for a PyTorch for MLP in PyTorch. This MLP is for a regression problem. The dimensionality of the output is 1. Dimensionality of input 1000. I want to use dropout and as layer norm and batch norm. That's enough. So now we're getting the import torch.nn as nn. Okay, this is working well. It's adding the dropout after the ReLU. Not ChatGPT like it dies halfway through and then it clears the answer. Ah, okay, so now it's using the functional API. That is not useful. Chat GPT network. Put that in there. We're gonna start copy pasting just in case. All right, here we go. Okay, so basically, if you're just joining here, what seems to be happening is that the GPT has a timeout. So we're like running into this timeout. Let's do this. A Python program for an MLP using PyTorch. This MLP is for a regression. This MLP for a regression problem, comma. It will predict a float number. And the dimensionality of the output is 1. The dimensionality of the input is 1280. I want to use dropout and normalizations such as layer norm and batch norm. Okay. we're going to copy here. Okay. Timed out, but we managed to get the copy. Okay. So this is using the Torch neural network module. So we saw it use the functional API, but now it's using the NN module. Let's see. It's making the linear input here, 3 linear layers, then a dropout, 2 layer norms. Goes through the first layer, then there's a layer norm, then there's a dropout, then the second layer, then there's a layer norm, then there's a dropout, and then there's the last layer here, which brings it down to dimensionality of 1. These don't have activation function. Can you add activation function to my model? Here you have the actual model creation and instantiation code. We have our train function. Training a MLP function for training an MLP. So we're just using VS Code Copilot here. So generating 1 at a time. Okay, so let's see what VS Code okay. These things here, the model, the loss, and the optimizer, we're going to put these if name equals almost had it there. Main. Okay, there you go. Have your model, have your criterion, your optimizer. Say Atom. Why is it giving the model parameters to Atom? Okay. And the learning rate. Then a CSV data loader for train CSV with a batch size of 32 and shuffle true. a test data loader for test CSV, batch size of 30, shuffle false, and it uses the train MLP. It's giving it the model, the train loader, the criterion optimizer, and the num epochs. Model, train loader, criterion optimizer, num epochs. Okay. Sometimes you have to check because the arguments and the keyword arguments here don't necessarily match, right? But here they do. Say print the epoch number. Okay. Loader. What is it not? It's a string. So there's a couple different CSV files we want to use here, right? Have train filtered embeddings, this one. And we have train filtered CSV. Right, Python. Let's make right Python code that reads in two CSV files. Want this one. Copy the whole. And puts them to a single, and joins them into one pandas data frame. Using the column seek ID. I only want the rows that from both data frames that share a sequence. I'm going to keep this copy code situation going, so we're copying here. Okay. Go ahead and open up our notebook main. So in our notebook, bottom here, let's put a little markdown here. Okay. Part 4. So in part 4, what we're doing here is we're importing pandas. We're reading in the 2 CSV files and train filtered. We are merging df1 with df2 on the sequence ID column. Print df merge head of 5, the first 5 of those. Okay, we want to actually we want to normalize the, go back up here and copy the normalize the pH and then normalize the TM. Actually, we need to normalize both the we need to normalize the pH not just on the train data set but also on the test data set. So let's take a little break here from what we were doing and let's go ahead and make a kind of master train DF. Go ahead and come back up here. We read the original train, the original test. Okay with that. Okay. We have the nulls. We remove the nulls. We filter out the ands, and then we write it train filtered. This is just like a kind of garbage thing here. Get rid of that. Let's move this here. Put this up here. Rerun that. Come back down here. Let's add a little markdown file here. Okay. EDA and normalization. So here we're plotting the pH, and here we're plotting the temperature maximum. So we need to have a new thing here. Join the train and test data frames for normalization. Add a new column called isTest. Combined df. Okay. And we are going to plot the, so we have a join, combine it. So this is the test and the train, and the temperature maximum, just that. So in order to normalize the pH, we want to do it on the combined data frame. So the test df pH equals test df pH minus pH mean, train df filtered. Okay. Write test df to test normalized. And write train df filtered to train filtered, normalized. Actually, we can just say normalized. And we don't actually want that there. We want to do it after we normalize the temperature maximum with target. So hit enter there. Okay, so now if we rerun these, they should be between 0 and so if we plus code here, train df filtered, that is not correct. It's normalized, but the like it's not necessarily between 0 and 1. I think that's fine. But let's also check the test df pH. And let's do the test. So everything in the test data set is actually quite acidic or basic, whatever that is. And then if we plot the pH for data frame, have that. Okay. Okay, so our things are normalized. Rid of this. So we have another code here. Another markdown. We're going to say data source to category. Train df data source unique. So you have 325 different categories for the data source. Want that? Do we want a 325 dimensional category vector? Can you write code to convert a pandas, and actually we want the combined df. How many is there total? There's 311 in the combined df. A panda data source column of a pandas frame into one hot category vector. Hot category. embedding of data source. Embedding of this is what we needed. Need to one hot encoding get dummies. You know what? I don't really think the data source is going to be honest. I think you're just going to give it a bunch of useless features that matter, and it might not learn faster. Is better off with just setting. Okay, so let's go back down to what we were doing here, where we were reading in CSV files. And we want to merge the train normalized file. So here, instead of train filtered, we're going to do train normalized .csv. And we're going to join it with the train filtered embeddings ESM. Then we're going to merge that. And we want so we only want the columns that are latent 0 all the way to latent 1280, and then we want pH, and we also want TM. DF sub set is going to be pH, TM, and then plus. So it's latent I for I in range 1280. Get only the columns we will use for training. And then let's go ahead and print the head of that just to see what that looks like. You have TM, pH, and then the latent. And then we want to write the df subset data frame to a file called train ready. We'll call it train ready. All right. Well, let's hit go on that. Got it. So save here, and we have our train ready. So our train ready has, there's the temperature maximum, the pH, and then there's 12,000 or 1,280 latent numbers, and then total dimensionality is 7,120. Okay. And let's do this do it for both of the data sets that third data set we have is so and ready. F string. Okay. Making test, making final train CSV. Train ready. Okay, so now we go back to our train. Import argparse. A argument parser object. Find command line argument. Batch size, I get that. CSP file. Train CSV file. On epochs. args dot epochs. Args dot batch size. Call it CSV file. Test CSV file. And let's do prediction file. Ren. We have train, test, and prediction. So this is Ren. Ren CSV file. Correct. Have test CSV file for the test data. Predict the labels for the test data. Save to CS file. Or wait up. Need our normal back up here. What did we normalize the temperature? Need the print em std. std. Rerun this. I think our def filtered might have gotten correct. Yeah, this looks. Normalizations for the main test data. denormalize the output. Okay. And store the prediction. Create a data frame with the prediction. And in the data frame, we're going to have sequence ID. Save the predictions to a red CSV text. Okay. We have a lot of different threads spinning. Let's add argument, add a mean and tmstd to make these command line arguments. So let's multi-cursor. Okay. The multi-cursor here is going to be args dot that, and then copy these values. Okay. How many roughly 2004? We're going to have to run the better on the test. Data, and then we test it. Train, it's going to this. Test is test normalized. You just test. And let's test. Test. There. Okay, so this is basically running our embedder on our test data set that we can settings. Make files. Copy that. Also, we do want and actually we crash that and put this all in an even bigger for loop. Call it or data set have embedding model, or data set in and then main filtered, and we'll have test. And have our set embedding model. And then we have our set and let's the train normalize, let's rename filtered normalized. And we'll this output it, we want data set ready embedding model. Okay. So let's open up our while we're stuff. Let's get this embedder working. So go ahead and run our first of all, we need to activate our Python environment. Then let's dash run embedder. Go ahead and start encoding our test data. Okay, so the test data does not have a TM. Go into our embedder and get rid of this line here. Run that. Just making sure that the test data set is getting embedded properly before we go into the model creation and training. Right. It seems to be working fine. We'll let that go ahead and chug along in the background. Let's go into our train.py file. Let's not do 100 epochs. Let's do epochs. Just to start. All right, now let's look at our data loader that we had. It takes in a CSV file, reads it in a frame, converts the data to PyTorch answer. This is not the data. Go back to actually, let's see if Copilot can help. Separate target from the input. What is df.pop? Return an item and drop. Okay, yeah, that is what we. Please log in to continue. ChatGPT, absolutely. Let's do this the old PyTorch data. I think the first thing. A little bit better. Make a class for the set. Okay, let's see what VS Code gives us. Give the CSV file the mean standard deviation. We don't actually need that because it's already normal. Separates the target from the input. That's correct. Convert the data frame into a PyTorch tensor. This is actually correct. Get a data loader from the trend data class. Wrap it. I don't actually need to make a custom data class. I can just, once I have the dataset class, I can just that data. So we have train loader equal copy paste the loader module, port that in there. Then let's do data loader. Go. Now let's do the same, but for the test loader. Okay. Let's not call it trend data. This is a terrible name. But ESM data. Better name. Okay, let's get rid of all this test stuff here. And let's go ahead and make a new script. Copy it, call it We're going to call it run main.sh. And add into our train file here, and let's say command line used to run the script. Go ahead and copy this. Put it inside our run train. Our batch size 2, box 2, and mean CSV file, test CSV file, and prediction. Okay. So first thing we're going to be using here actually kill that. We don't need it. We have our thing pretty good now. We have 400 lines or 400 rows for the test, so let's actually go ahead and just put that in there. So the test CSV file is going to this. Train CSV file. Go back, or no, that's not going to be the one. Is going to be this one. Ready. And our predictions. Go back, we're going to need to run this. So let's not do it for this 600. The error TM not in index. If dataset is test, are we getting rid of the maximum? It's not. If the data set is not test, then that. Inside our train function, we're gonna have to actually do a similar thing. So I think let's actually make two different data sets here. Let's do ESM, or let's do train data. So F2, yeah. And we're also going to have test data. And in this case, you're not going to use the you're gonna use the sequence ID and then not use this. So in the train with pH and latent, test only use seek ID f dot pop seek ID, and then self dot input df of just pH latents. Dot input values, have self dot input dot values. In the train, you're giving it data frame, or you're giving it the input and then the target. In the test data, you want the input, but then you want the sequence. Go down here, and we make a loader for the train data. Here we're making a loader for the test data. And yeah, so the thing is, there's a difference here between train and validation. This is more the lid data. So this part here, validation, that want order for the actual prediction. Right. That's a test loader, and the test loader doesn't give you input target, it gives you input sequence ID. Actually, why are we asking the internet when we could just ask? Add prediction and sequence ID as row predictions data frame. dot data frame. I think maybe we can put them in a dictionary and then that. Try this. This. Okay, we're gonna try to run this. Almost guaranteed not gonna work, but then we debug it, and that's what. Here we'll dot dash run dot sh. Namespace object has no attribute num epochs. Okay, so num epochs. We just called it epochs. Let's call it num epochs. Epochs here. Mat1 and mat2 shapes cannot be multiplied. Okay, so there's a problem here with the actual MLP itself. So where is this problem happening? So line 97 of output. Okay, so in our train MLP, we have line 97 here, the forward pass. Have self FC1 of X. Okay, so the issue here is that we added the pH, which means the dimensionality of our input is no longer 1280, it's 1281. That. Loss dot backwards. Found D-type double but expected float. So there's this library that I heard about. library for debugging tensor PyTorch. Put a trace in. Let's look at actual. Okay, so we're in the training. This is what our input looks like. It's a 2 by 1281 tensor. What does our target look like? Our target is a size 2. So we need to increase the size of that. What do we do? Input dot type float target dot dtype float 60. Okay. So convert target into a PyTorch. All right, so now if we run it, input dot shape dot type, we have a 2 by 1281 and it's a float 32. And if we target dot shape target dot type float 32, at least the data type is correct, but the size is incorrect. Add batch dimension to target. Unsqueeze. Let's rerun this. Input dot shape. Input shape. Input dot dtype. Target dot shape. Target dot dtype. All right, so we have float 32s on both of them. Both of them have the batch dimension of 2, and the next dimension is either 1281 for the input or 1 for the output. So that is good to go. Go ahead and remove our breakpoint here. Move that breakpoint, save, run it. And we're training. Can't call numpy on the tensor that requires grad. Okay, so the problem here is that we're evaluating with torch dot no grad output. Okay, let's go into our run train and let's make it just one epoch. Let's run that. All right, and it outputted something. let's go into, let's see what we got here. Predictions, embeddings, ESM2. Okay, I mean, this is what we want. The data types are a little weird. We need to convert this into NumPy and then convert this into not a list. But we're there. We have the sequence ID and we have the temperature maximum, and that does look like a correct temperature maximum. So let's go ahead and go back to our train. We want output dot Latin dot numpy sequence ID dot numpy. Let's run that. Now let's look at our prediction. That is what we want, guys, right there. Sequence ID and temperature maximum. Okay. So now that we have our sequence ID and our temperature maximum, let's train this for significantly longer. Well, first of all, let's save. Go here, let's clear all the outputs. Let's save that again. Let's go into the GitHub and we'll say working training MLP. Hit that. So we're going to need to run this again. Right? Let's do this. So test CSV. And let's put this variable here, train CSV. That and that. That's the embedder. The train. And then we'll do one on the ESMv1. And we'll do, I don't know, 50 bucks. Batch size of maybe 8. Or actually 30. Okay. Ideally, we'd want some kind of validation here, and we'd be able to log this and then plot it and then see it. but I think for now, and we're just going to want to, the next thing we got to do is run this in better and then wait time that it takes that. Go ahead and save. Better. Run scripts. Plus it changes. Close that. And let's go ahead and close this here, and then we're going to run the embedder. And we're going to let that run pretty much all day and all night. Okay. So we'll leave it at that. Tomorrow we'll come back and see what kind of predictions we can get from this. Thanks for watching, and see you guys tomorrow.